Welcome to Get Your FRQ On. This question is from the 2007 AB exam. It is question number 6, and it is not calculator active. In the question stem, we are given a basic function f of x, k times the square root of x minus the natural log of x, and we are asked to find both the first and second derivatives of f. It may help to rewrite f of x as k times x to the 1/2 minus the natural log of x so that we can use the power rule. If we do that, we find that the derivative of f, the first derivative, is k over 2 times x to the minus 1/2 minus 1 over x, or equivalently k over 2 square root x minus 1 over x. All right, so the f prime, the first derivative part, is done. And now we just need to differentiate again to find the second derivative. The second derivative, using the power rule a second time, would get us negative k, or the opposite of k, over 4 times x to the negative 3/2 plus 1 over x squared, or equivalently the opposite of k, over 4 times the square root of x cubed plus 1 over x squared. Not a very difficult task. We just have to be able to differentiate using the power rule and the rule for the derivative of a natural log function. In part B, we are asked to find the specific value of k such that f has a critical point at x equals 1, and then also to determine if that critical point is a minimum, maximum, or neither. All right, since we want f of x to have a critical point at x equals 1, we need to determine the value or values of k such that the derivative at x equals 1 is equal to 0. Well, if we differentiate f, which we've already done, and evaluate that at x equals 1, we get k over 2 times the square root of 1 minus 1 equals 0. Solving this equation gives us a solution of k equals 2, and note that it is the only solution to this equation. If we want to determine whether it's a maximum, minimum, or neither, we can evaluate f double prime at x equals 1 to determine the concavity. So we plug in 1 into the second derivative. Consequently, f double prime at 1 is positive 1/2, which is greater than 0. Right, this indicates that the graph of f is concave up at x equals 1. And since the derivative by the work above, our selection of k, guarantees that f prime of 1 is equal to 0, if it's concave up, we have a relative minimum at x equals 1 as required. For part C of this question, we are asked for what value of k does the function f have an inflection point on the x-axis? So there's a couple of things we have to account for here. We need to guarantee that f of x will have an inflection point on the x-axis, and we have to determine the value of k for which this is done. Now, in order for the inflection point to be on the x-axis, the y-coordinate, wherever that inflection point occurs, must be 0, while the second derivative is 0 as well. So we have two different things we have to find. We have to figure out when will the second derivative be 0, and then how can we guarantee that the point where this happens will end up on the x-axis. Well, if I take my derivative, the opposite of k over 4 times x to the negative 3/2 plus 1 over x squared, and I want that to equal 0, right? That would imply that 1 over x squared is equal to k over 4 times x to the negative 3/2. And solving this for k, we get 4 over the square root of x, or 4 times x to the negative 1/2, depending on how you worked with the algebra there. All right, so in order to guarantee that f double prime is equal to 0, k would have to equal 4 over the square root of x for whatever x that occurs at. Okay. The actual function f of x, k times the square root of x minus the natural log of x, if we want that to be 0, guaranteeing that the point is on the x-axis, Well, that would imply that k times the square root of x is equal to the natural log of x, and therefore that k is equal to the natural log of x divided by the square root of x. Okay, if we want both of those things to be true, and both of those expressions are equal to k, then by substitution, they must be equal to each other. So we solve the equation. 4 over the square root of x equals the natural log of x over the square root of x, which implies that 4 is equal to the natural log of x, which further implies that x is e to the 4th power. If x is e to the 4th power, the square root of e to the 4th is e squared, so the value of k that would guarantee this would be 4 over e squared.